In this video, we're going to begin at the bottom of page 22 in our workbook, where we're going to summarize some information about dot products and cross products. So first of all, we have this theorem, which gives us a geometric definition or interpretation of the dot product. So we saw in our previous video that to compute the dot product between two vectors, we use multiplication. We multiply each corresponding component together and then add the result. Equivalently, the dot product is equal to the following formula. So here we have the length or norm of both v times w times the cosine of theta, where theta is the angle between v and w. So if we want to draw some pictures here, if this is v, this is w, theta is the angle between v and w. So the dot product tells us information about both the lengths of our vectors and the angle between our vectors. And then in our next theorem, we have geometric definitions of the cross product. So here again, let v and w be vectors in three-dimensional space. Then v cross w has the following three properties. So first of all, v cross w is going to be perpendicular to both v and w. Now we saw this in a previous example when we computed a cross product. Also, v cross w points in the direction determined by the right-hand rule. So there is an image posted on our Canvas page demonstrating the right-hand rule. And we can see how that applies in this image. So if we're looking at v cross w, the right-hand rule says we take our index finger, stick it in the direction of v first. There's going to be our finger. And then if we take our fingers, the rest of our fingers, and curl them in the direction of w. Let's see if I can draw our hand here. Okay, we kind of get it. Then our thumb will point in the direction of v cross w. Okay, yeah, I highly recommend looking at the image I have posted instead of this drawing. But you can do that for yourself. Go ahead and do that right now. So take your finger, put it in the direction of V, and then curl your fingers towards W. You'll see that your thumb points up in this direction. So that will mean V cross W will be in this direction. And then alternatively, if we had started with instead W cross V, our hand would face downward, index finger here. I'm not going to draw it out, but you can do it for yourself in front of you right now. Index finger near W, and then curl your fingers towards V. You'll see that your thumb points downward in this direction. And then the third property is that the length of V cross W equals the area of the parallelogram determined by our vectors V and W. So what does that mean? So how do we see a parallelogram with V and W? Well, we see that V and W can form two sides of a parallelogram. So if we extend V with another copy of W, and then another copy of V here, we form a parallelogram. So that area is equal to the length of V cross W. So the area is equal to the magnitude of V cross W. So super interesting stuff. So both the dot product and the cross product give us some really interesting information about our vectors. All right, so let's continue the summary. So a few notes on dot and cross products. So the cross product of two vectors is what kind of object? Well, the cross product gives us another vector. So we're going to fill in vector here. So cross product is a vector, but the dot product, on the other hand, of two vectors is a scalar. That's an important difference between these two products. What we get out is different in the end. Cross product, we get a vector. Dot product, we get a scalar. And point number 2 here, to find a vector perpendicular to both V and W, What can we do? Well, we can calculate the cross product between V and W. So that is one reason why the cross product is so important. And then third, the vectors V and W are orthogonal, meaning they form a right angle. If and only if their dot product is 0. So these are some really important and key facts and information that we have about dot and cross products.